This video continues our introduction to an important statistical tool, the hypothesis test. We will continue with the example we began in the last video, our thought experiment regarding tossing coins. And as we reflect upon that example, we will realize that we essentially went through a 6-step process. Let's take a moment and reflect upon, break down those 6 steps. We began step 1 by defining 2 hypotheses, 2 statements about how a particular corner of the universe operates. One statement is called the null hypothesis. It's a statement that nothing special is happening here. Null is a synonym for nothing, for zero. The null hypothesis is the nothing's going on here. Nothing unusual is happening. There is no effect of the phenomenon of interest. In our example, the null hypothesis was that the coin was fair. Nothing special about the coin. The alternative to the null hypothesis is called the alternative hypothesis. It's a statement that something is happening. Something is going on. There is an effect here. In our example, that the coin is not fair. Something is pushing it out of true. Once we defined our hypotheses, we then, step 2, quantified them. I asked you what you meant by a fair coin, and you said a fair coin is 50-50 randomly. You put a number on things. More formally, our null hypothesis that the coin was fair, we can write in mathematical symbols like this. H sub 0, null hypothesis, is pi here is not 3.14159265358, etc., 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 etc. Pi here is a symbol for a population proportion. The true unknown proportion of times, the true unknown population chance of getting heads is 50% if it's a fair coin. And if it's not a fair coin, our alternative hypothesis, H sub A, and some books will write this as H sub 1, either way, our alternative hypothesis is that that population proportion chance of getting heads is not half. So we took our original hypotheses that the coin was fair or not, and we translated them into numbers. We translated them into a quantitative statement that that true chance of getting heads was 50% or not. Once we did that, we then, step 3, went out and collected data. We went out and tossed the coin. And once we had those data in hand, step 4, we computed some things. Now, you didn't necessarily sit down at your calculator and work out a number, but in your mind you computed 2 quantities. I asked you, 99.1, is that a fair coin? And you said no. Why not? Because 99.1 was not very close to 50-50. You computed in your mind a test statistic, in jargon terms, a distance between what we got for our data and what we actually expected to get. 99.1, that wasn't very close. On the other hand, 51.49, that was pretty close. we computed in our mind a test statistic. The other thing we computed in our mind is something that statisticians call a p-value. It's the probability of getting the data if the null is true. 99 heads and 1 tail. Is that a fair coin? Could we get 99-1 from a fair coin? We could, but it's very unlikely. In our mind, we computed a probability. 51-49, that happens a lot. In our mind, we cognitively obtained a probability. And so step 4, we compute two things. A test statistic, how close our data are to what we expected to get, and a probability, the chance of obtaining those data if the null is true. Once we have those numbers, at that point step 5, we made a statistical decision. In jargon terms, we did one of two things. We might reject the null hypothesis. We got 99 heads and 1 tail. We don't think the coin is fair. We will do that if that test statistic is big. We're a long ways away from what we expected to get, 99-1. And our p-value is small. It could happen, 99-1, but it's awfully unlikely. If we do not reject the null hypothesis, then we don't reject the null hypothesis. 51-49. Pretty close to what we expected to get, 50-50. So that test statistic is pretty small. It happens a lot from a fair coin. Our p-value is big, and so we do not reject the null hypothesis. Please note, double star wake up time, never, 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 never the null hypothesis. We do not use the A word in this class. If I ever hear any of you the null hypothesis, I will spank you. I will wash your mouth out with soap. Why? Because you can't prove a null. 51-49 does not prove that that coin is fair. We never, ever, ever the null hypothesis. We merely reject it or don't reject it. Once we've made the decision to reject or not reject, step 6, we need to put that decision back in its original context, because we don't care about the hypotheses. We want to know something about our coin. If we rejected the null hypothesis, that's a fairly definitive statement. We do have enough evidence. There is enough evidence to conclude that coin is biased. It's not fair. Whereas if we're not rejecting, that's a weaker statement. It's a statement of not enough evidence. Not enough evidence to conclude the coin is biased, and we assume the null is true till we've seen evidence to the contrary. We'll continue believing the coin is fair till we see sufficiently strong evidence. So those are our 6 steps. We define hypotheses, we quantify them. At that point, we go out and collect some data. Based upon that data, we'll compute a test statistic and a p-value. The test statistic measures how close the data are to what we expected. The p-value tells us how likely it is to get those data in null hypothesis world. At that point, we make a decision. We will either reject the null hypothesis or we don't reject the null hypothesis. And then make a decision whether we do or do not have enough evidence to make a statement about the actual wording of the null hypothesis in the real world scenario it applies to. Notice, by the way, that this is a reasoning process that we understood, we knew about before we took a stats class. You don't need a statistics class to understand hypothesis testing. It's something we do instinctually all the time. The hard part of the process is that step 4, those computations. That's what statistics teaches us to do. And those will be the focus of the next video.